Today we're going to talk a few things about monitoring, a few ideas that we have with regards to how monitoring should be done, what things are good, what things are bad, and how Kamon can help you monitor your applications. We're a small crowd. If you have any issues or problems during the talk, just wave or something, and we can solve questions and move on. So one disclaimer here is that there is a new Kamon version that is about to be released. And what I'm going to talk about today is including this new version of Kamon, not the previous one. So if you were using it already and you see something that's like, no, it doesn't do that. So please stay calm. This is about the new version that should be out next week. So please just enjoy and keep your hateful comments in case they come. Okay? So let's go about a typical conversation. We all like to brag about how fast our things are, how big our systems are at processing stuff. And then when I get people who are into this mood of bragging, I always ask, what volumes are we talking about? And it's usually like a lot. Like it's a lot of transactions per second, like a lot. But how much is that lot? Well, people usually don't know. What response times are we seeing when we're talking about these things? Is this like milliseconds or hundreds of milliseconds or seconds? Like, oh yeah, it's fast. Like usually it's just fast and they have no idea. And then you ask them, well, and is it fast all the time? And then you see this in their face when they're like, yeah, they're like, they're not sure. Like you know that they just realized that they don't know that. And then you came to this question, like, do you even monitor? Do you even know what is happening in your services? What is running on production? What is happening there? Because the users that use your service, your platform, your product, whatever it is, they're affected by your negligence of not knowing what is happening there. So do you even monitor? And then we start talking about how to properly monitor some applications. So when you want to monitor, usually there are three things. Like people always refer to these three things as the main things about monitoring. One is gathering metrics, another one is logging, and the other one is tracing on your application. And all of these things are related, and some people like to just log everything and just grab the logs, and then you will find there what you need, or you derive metrics out of logs. Like somehow you relate them and you generate metrics from there. Some other people are really into tracing, and like tracing is how you do it, and then you sample, and then when you sample, you generate metrics on the sample data, and then you miss certain things that are actually happening. And if you do metrics, then sometimes people do metrics, but they don't do it in a conscious way. Like they don't know what they're doing, they just know that they're getting some numbers out of the computer, and they think that's good. I'm measuring, all is good. So, when you see that there are all these options, first piece of advice I can give you, if you are not monitoring, then create a plan, small plan on how you will start monitor your application, especially what is important to you. It's obvious that you need to monitor, but what is important? For some people, just knowing that the service is up is enough. Like if it's running, it's fine. Like if it's slow, nobody cares because that's some internal stuff using the bank and they can wait 10 seconds for a report to render. That's not a problem. Then uptime is your concern. If you have end users, then that's a different issue because like end users like out there on the internet, they're not going to wait for you. If your service is slow, they will go use someone else's service. So your service has to be fast, responsive, consistent. It cannot be like fast, fast, slow, fast, 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 slow. It has to be consistent, and you have to be aware of whether you're being consistent or not, and whether you are giving correct answers to your users. Like, are you providing service correctly? Because fast might be fast because it's failing fast on certain situations. So you need to keep track of these things, but keep it simple. Like, we have had situations in which people say, oh, we want to start monitoring. What do you want to monitor? Everything. Put everything, all the metrics, all the traces, all, put it there. And that is just a recipe to failure. Because if you don't know what is important to you, then how can a monitoring tool give you something without some input? So start introspecting and define what is important to you, to your projects, to keep your application alive. Then start finding a common idiom to express what you need. There is a book, Site Reliability Engineering, from Google, Site Reliability Engineering team. It's free, you can find it online, read it, it's amazing, it has a lot of very useful information. One of the things that they talk about is defining service level objectives. That is, what does it mean for you that your service is good? And you can have this with regards to uptime or latency. So if you want to talk about availability, think about numbers of nines, like how many nines of availability do I want to have? And if you're talking about latency, you have to use percentiles, and we're going to see why in a second. So if we're talking about uptime, well, this is a simple example of how you can do. Okay, you can do 2 nines. That's 14 minutes per day that your service is allowed to be down. Are you good with that? Maybe yes, maybe no. If you want 3 nines and you have 1.5 minutes a day that you can be down, depending on how often you deploy, how many things you do when you deploy, if you don't have proper rolling deploys, blah, 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 you might be already breaking 3 nines that you might think you have. So think about these numbers. Think about another scale when you see it as a month and a month scale. Like, I'm allowed to be 7 hours down if I want 2 nines during a month. Is that reasonable for you? Like, what is reasonable for you might not be for me or for some other people, but you have to think about your case and what's really good for you, for your use case, okay? And when it comes to latency, we talk about percentiles. This usually goes, well, this goes in steps. You have, let's say, 50th percentile has to be 50 milliseconds, then 100 milliseconds for the 90th percentile, 99, 300 milliseconds, and then nothing above 1 second. This is pretty simple. You have steps. These steps should be reasonable in accordance to the requirements of your application, but they should be defined in terms of percentiles. Why? I'm going to show you some charts, and I want you to tell me what is in common with all of them. So this is just random values. Random values thrown between 1 and 100. All of them are evenly distributed, like everything looks the same. These are values that go from 1 to 100, and we're recording always the same number of measurements in each bucket. All of them look the same. This is going from 26 to 100 and descending the number of buckets we put there every time we go. That is some crazy ideas that I came up with. Then there is this. Some things here, something there. If you're measuring latency on this, all of these things have these percentile distributions. All of them are different, but all of them have one thing in common. What is that thing? Who can guess? They look pretty different. They were taken very differently, but all of them have the same average. Okay? For all of those charts, the average is 50 nanoseconds, assuming the scale is in nanoseconds. So if you are monitoring, this is how latency really looks like. You have a bunch of measurements in one part of this thing, and then a long tail that might be long, like here is not that long, it's like up to 30 milliseconds, but usually this tail can go really far depending on garbage collection pauses and so on. So if you are using averages, then you're being misled. Like whatever you get from this single number that is the average might be generated by all these different sorts of behaviors. So what you want to care about is not the value of the average, but the behavior of the latency. And the behavior is defined by the percentiles. So if you take this and you look at the percentile distribution of that distribution that I show, you see that even though here you might be thinking, yeah, everything is around 2 milliseconds because everything seems to be right there. Actually, the values you should be looking at when you're looking at your service levels are the 90th percentile, which was 4 point something milliseconds, and the 99 was 8 point something milliseconds as well. That is not obvious from this other chart that the 90th and the 99th percentile are that big, because everything seems to be skewed to the left of the chart. So when you're talking about latency, talk about percentiles. Always have steps and limits for each of these steps. Now, one more thing. So never use averages. Never, ever, ever. Don't do it. You will burn in monitoring hell if you do. Like, that's a no-go. Don't do averages, because those averages are misleading. Following on that, don't average summaries. One thing that people usually don't know is that, well, you have a summary from one server, a summary from another, and a summary from another. So you have the 90th percentile from each of these ones. And then how do you put them together in one chart? Well, they average these three values, and then you get it on the screen. That's what many of the tools out there do, or people do without knowing that they're making a mistake. But if you're having a summary of a summary, whatever number you get out of that is a lie. So don't lie to yourself, and try to search for the proper values that really tell you how the latency is behaving in your application. Now, get to know your tools. How many of you use CodaHell metrics or Dropwizard metrics, or have used it before? I was one of the people using it, and it happens to a lot of people that naively you just put it in your class path. You see, this is how I do. I have a histogram timer, put here, put there. Boom, I have measurements. And one thing that people usually don't know is that the default implementation of the histogram, well, not the histogram, the reservoir that is inside the histogram uses exponentially decaying reservoir. What does it mean? Like, long story short, it randomly samples the data that you put in, and it assumes that you're putting there represents a normal distribution. And I don't know about you, but this for me is not a normal distribution. If you throw this data in this histogram, then it creates a statistical approximation of the model so that it can give you some percentiles, but those are based on this estimation and the premise that the data has a normal distribution, which it doesn't. So I took all this data here, and I recorded again in Dropwizard histogram and Kamon histogram. Kamon uses the HDR histogram internally. And these were the results I got. In Kamon histogram, you get the max is 29 milliseconds. Here, it was 10 milliseconds. That's weird. 99.99, 10 here, 25 there. What happened there? More interestingly, the implementation is time dependent. So I run this again with the exact same input, and I get different values from the CodaHell histogram with the default implementation. I run it again, different values again. People don't know that. And worst thing is, it's clearly documented. This is the expected behavior. This is not a bug. This is how it works, and that's what the documentation says it does. Just people are not aware that this thing happened. So if you are using right now CodaHell metrics or Dropwizard metrics, whatever you want to call it, go check your numbers, because you might be affected by this behavior without knowing it. So one very sincere piece of advice: get to know your tools and the limitations of the tools you're using. If you want to stick with them, there is an HDR histogram reservoir that you can use to put inside CodaHell metrics. You still have the issue that the report inside of this does not really expose the nature of the HDR histogram, so you will be exposing summaries, and the summaries cannot be aggregated. But you will get real percentiles if you are using the HDR histogram reservoir for the Dropwizard metrics. Next advice: accept that your performance intuition sucks most of the time. It happens pretty often that you see something, you wrote some code like, yeah, this cannot possibly be a bottleneck. Like, this is going to run so fast because I optimized it so much that it's just going to be awesome. and then it breaks in production. Then when you start debugging, you realize that, oh, this awesome code that you wrote makes your application slower. The only way that you have to properly know what's going on is to measure. So forget about your intuition, measure, and then when you confirm that something is good, then you can say it with data, not with just some hunch that you said, oh, yeah, this has to be good. So forget about intuition, instrument, and measure and see with the data. And one more thing, log with context. One thing that happens a lot is that you log stuff, and then you cannot make sense of what it is that is in the logs. And that's pretty shitty, and actually it happened to me this morning that I found some log lines that I just didn't know what requests were they related to because of some misconfiguration. And when you log it, I think it's really important you can relate all log statements that are related to a single request together, okay? Just have some sort of request ID that you can attach to all of these logs so you can then aggregate them together. Regardless of where you put your logs in Elasticsearch or some paid service or whatever, just make sure that they can be related somehow. Now, how does Kamon help you achieve these things? So first, in case you didn't hear about it before, Kamon is an open source project for monitoring on the JVM. It's not tied to Scala or Akka or Play. It's a monitoring tool for the JVM. It has a bit more 4 years of effort in there. It has a metrics and tracing API, so it's not just about doing metrics. It also has an open tracing compatible tracer, since version 1.0. And also brings a lot of instrumentation for common libraries. So if you're using Play, Scala Futures, or Akka, there is already instrumentation that gives a lot of good things here that we're going to see in a second. And it has a separate API for collecting metrics and for reporting metrics to the backend. So when you start recording metrics with Kamon, you are not tied to one specific backend. You can just do what we say here. You instrument once, you start recording your things, your traces, your metrics, whatever, with Kamon, and then you can report to Datadog, to New Relic, to StatsD, to Prometheus, to whatever thing you want. You can write your own reporter if you want. So how does it look like? Well, the metrics API is pretty simple. Kamon, give me a histogram with this name. I record things there. You have a simple model, it's just a metric name, and you can refine a metric name by providing tags. So in this second example here, you have a counter, and then you provide a tag code with the value 500, and then you get a refined version of this counter that has the same name, but with the tag code with the value 500 applied or 5400. Okay. Another cool thing about this is that Kamon keeps track of all these instances internally. So if you up here requested for this histogram for the processing time, and then somewhere else in the app you request Kamon for a histogram with the same characteristics, it's going to give you back this same instance. So you don't need to be passing instances around as long as you know the name of the metric you're searching for. You can just request it again, and you will get the same instance all the time. On the tracing API, we had some sort of tracing. We had something that we were using to propagate context locally on the same JVM, and a few things that would go across VM, but it wasn't enough. And I think this is one of the biggest changes we have in Kamon 1.0, which is that we adopted the open tracing specification, and now our tracer is an open tracing tracer. Open tracing is an initiative that provides an API and semantics for tracing that are language agnostic. So the same concepts that we're using here are the concepts that people are using for creating a tracer for Go or for Python. And one interesting thing about it is interoperability. So the concepts that you're learning by using this, you can take with you when you go to another community. You can properly communicate with someone in another team in your company and talk in terms of spans and span context and injecting, extracting, things that are specified in the open tracing spec and will allow your tracing not to be limited to the JVM, but for any kind of platform that supports the that complies to the open tracing specification. The API is pretty simple. Kamon, build the span, put tags, set active. That's an interesting thing, because one thing that was not available in open tracing before was local active span storage. That's what we were calling before the current trace context in Kamon. They came up with a specification for that, and then when we saw, well, open tracing has everything we need and more, then we ditched what we did and we adopted this so that we're compatible with more stuff. That brings a bit more value for you because we have a lot of instrumentation done, but with this, you can put Kamon underneath any other open tracing enabled instrumentation. So if there's some instrumentation available for Spring, you just put Kamon underneath and you get all the benefits of that instrumentation without having to do anything. And adding reporters also became a bit simpler. We before had Akka in Kamon core for managing this part specifically, these subscriptions, but we ended up going with a simpler model. You just implement a trace at Kamon that add reporter, give me an instance of your reporter, that's it. If you want to create a reporter, implement one of these traces, either for metric reporter or span reporter, and that's it, okay? But I'm lazy. Like, do I have to write code and do all these things to actually get metrics? Because then, like, where's the fun? Like, I want to go for coffee at 5. And then it turns out that it's not necessary at all. It depends on what you want to do. In most cases, you can just get the benefits of the the instrumentation that is already available, and then move on with that. Let's take a quick look at how would you do it if you were doing it for a Play application. So there's Kamon core, that is just the core metrics and tracing API. There is no instrumentation there. It's just these APIs. But Kamon Scala has instrumentation that knows how to deal with Scala futures. Kamon Akka knows how to deal with actors and all the asynchronicity that comes with them. Kamon Play knows how to recognize when a request starts and when a request ends in a Play application. Executors allow you to monitor thread pools, and Prometheus allows you to export this data to, let's say, Prometheus. So if I want to add all of these things to my application, how do I do it? Well, you first add the dependencies. Sorry for the big snapshot names, but this will be online pretty soon. You add the dependencies. You configure your application. What are we configuring here? Adding a dependency injection module. This will ensure that Kamon is properly configured with the Play internal configuration. It gets resolved a little bit differently when you're running in development. So this makes sure that this works nice in development and when running in production mode. You give a name to your service because this name can be exported to reporters. And you add filters. What are these filters for? Well, the names seem to be pretty descriptive. Akka actor, Akka dispatcher, Akka router. You cannot just monitor every single actor because you don't know how many actors you will have in advance. You could have thousands of actors, short-lived actors that you just don't care about. So all these instrumentations that pick up things for you will provide you with filters that you can configure. You can configure with includes and exclude patterns, and it's a collection. You can add many of them. They can be regex or glob patterns. And this allows you to select what parts of Akka you want to monitor. So you want all the dispatchers to just put this double star, and boom, you get monitored. All your dispatchers get monitored right away. And one extra thing, is particular for Play, that's why I wanted to mention it, is that running with AspectJ, because all this instrumentation comes with aspects that need to be applied, and we're typically using low-time weaving for that. With Play, that's special because of the way it works, the way it handles the class pets and stuff. So we created an SVT plugin that overrides a few things on how Play runs the application, how it gets the class pets, so that we can actually instrument your application while running on development mode. This has nothing to do with production mode, just in development. But if you this, then it's going to be a bit painful to try to use Kamon. So if you're using Kamon with Play, please add this SVT module, and you will just run like nothing happened. And then what do you get by doing this? You just added configuration, no changes on anything, just config here, config there. And then imagine that you have a controller that looks like this. You have this line logger info in the controller. This is an async controller, and then you have a future that you're doing something with it, and then you map that future, and you're also logging something over there. When all these things happen, they're going to happen on different threads. And one of the most common things that, like the first painful thing here is when you have several requests running concurrently, to which of these requests does this log belong? Because maybe you're being smarter than me there, and you're actually putting some proper context about what is this request doing. So maybe some data is failing, but you don't know which one is the one that is failing. And if you log this, you get something like this. Like you can see the threads where these things are happening in this and that and the other, but you cannot correlate these. There's supposed to be one in the controller, one in the future, and actually there is another log line in the actor itself. And like you don't know which one belongs to which one. They are definitely not tied to the same thread because that's not how things work. But what can we do about it? Well, Kamon has a trace management for you. So when a request comes into play, Kamon starts an active span for this request. It gives a name to this operation, and it will finish it when the response goes back to the client. It means that when your controller is running, Kamon already knows that this is an ongoing operation. It already assigned a trace ID for it. It already assigned a name. So what you can do is just do this. Add the trace ID to the pattern you're doing, and Kamon will automatically put this thing in the MDC when you're logging. So these IDs that you see here are the trace IDs, and you will notice that there are 3 of each because there are 3 log lines related to each of these things. That might seem stupid, but I don't know if she's here now. There was one of our users that was here today, and she said, the only thing we're using from Kamon is this. This is a savior for us when we're debugging production. We want metrics, we want to go further, but this alone makes our day every time we have to debug something. Because the more things you have, the more components in your applications or even microservices, because these things can then start crossing the JVM boundaries, the more benefits you will get by just putting a unique request identifier in your logs. How does it work? Well, there is a challenge in the way these things work. This is the traditional way of doing stuff. Like if you were having serverless, everything was so easy. You have one thread. Imagine that this orange line here is a thread, and it is attached to the transaction, so the request that you're processing. So for the whole lifetime of this request, you will have that. And you might submit tasks to an executor service represented by these other yellow things over here. But usually, the main thread will then join these things, or like wait for these 2 things to complete, and then continue working on something. So if you wanted to track or keep context between the beginning and the finishing of a request, well, you just put it in a thread local, and that's it. And you might have some additional tools that will propagate this when you submit something into the executor service, but it will just work simply. But when you go into the reactive model, then things are different. There is no more thread per request. It's just events all over the place. Every time you flat map a future, every time you send a message to an actor, you reply. Every time you do anything, even actor creation happens asynchronously. So all these things that happen as events no longer allow you to have this safety of just putting things in a thread local. But we had this situation, and then we started to investigate how do futures work, how do actors work, and then we came up with some instrumentation that does the work for you. The actor instrumentation knows what it means to send a message to an actor, so it captures the active span from the thread where this is happening, and then activates it on the other thread while this message is being processed, and then deactivates it again. Activating and deactivating basically means putting it something in a thread local, but in a controlled fashion. You put it and you take it only for the span of time that you know is necessary. It works with futures, with actors, with routers, and even across JVMs, because a cool thing about the instrumentation is that if you do an HTTP request to another service, well, Kamon also knows how to handle that, and it will inject the tracing headers in the outgoing request so that when it comes to the other side, if the other side is also a Play application, well, it will know about it, will take this and continue the same trace. So you log here, you log there, you have the same ID. And if you have a distributed tracing backend, like for example, Yaeger from Uber or Zipkin from Twitter, then you can then just take all this information and flush it there. So you have a Prometheus backend, and now, well, there's a lot of information, but this is actors being monitored with Kamon. And we have this thing that I don't know how we didn't know it before, but Prometheus is awesome. Why is it awesome? Because Prometheus is a tool that has histograms in buckets. Like, it's basically the same thing we do in Kamon. The HDR histogram has buckets. It's a exponential system of linear buckets. That might sound fancy. It's just a bunch of buckets that are nicely aligned so that everything is up to 1% away from the value you're actually going to record. So everything is precise when you put it there, up to 1%. And in Prometheus, you can configure buckets, and these buckets are properly aggregated. It means that if you have a histogram from one server, a histogram from another, you aggregate the buckets, you can get the proper percentile when you aggregate across nodes. And that's the common case, because now it doesn't happen that you have one instance of your application running. It's always going to be a handful of them. And then the fact that you can properly aggregate this information from different instances and get a proper, nicely approximated percentile is a good thing that we like about Prometheus, and we will be pushing a lot for Prometheus to be like the default thing. Like, if you don't know what to do with monitoring, put Kamon, put Prometheus, have fun, okay? So there's also Yaeger Tracing. This is the only tracing backend we have now. This was, it doesn't look very nice, okay? But this was taken last night from one of our applications. We're already running this latest Kamon version in production to see if it breaks somehow. And this is taken from one of our applications. And these applications are not Play. This is Akka HTTP. We didn't publish yet the tracing part for Akka HTTP, but we will be doing so in the next few days. So you can get metrics, report them anywhere you want. You have StatsD, InfluxDB, Graphite, New Relic. You have all these backends where you can send this metrics information. For tracing, we only have Yaeger, but we are also planning to add Zipkin. So I think those are the two most important open source options, and they're going to be available. And we're on the road to 1.0. What does it mean? Documentation, a lot. Like, you have no idea how painful it is to maintain documentation. And we broke everything because this API in 1.0 is not compatible with the previous one, so we need to rewrite a good chunk of the documentation plus migration guides so that people can easily move from one version to another. And this is our priority now. One priority, documentation. Second priority, getting all the modules migrated to the new APIs. That's not that hard, actually. I think the two most complicated ones were the Play and the Akka one. We migrated, they work fine, so we're pretty happy with how it's going. And then spam people with information. Like, we noticed that it's hard for people to start using Kamon. And usually it's not about Kamon, it's about some other stuff, like how do I set the AspectJ Weaver, or these things about the filters. Sometimes people are not aware that they should add some filters. So we want to start creating like mini guides. Oh, you're using Akka, this is how you set up Akka with Kamon. Oh, you're using Play, this is how you do it. Because right now the documentation was more like, this is what Kamon is, and this is what Play does, but it was not very well connected. So we have to get better at documenting the thing, making it easier for people to start using it, and start publishing every single module in the 1.0 thing. When this happens, we will not have anymore this thing that we're releasing all modules with the same version. We will hopefully have a stable 1.0 version, and then all other modules will be able to evolve independently. Okay? One more thing before I switch this one. We are going to wait a little bit for the open tracing specification to reach 1.0. There are already discussions for this to being published, and we don't want to fully publish 1.0 until that happens. So they commit not to breaking the API, we commit not to breaking the API. So you will see RC1 for a few weeks, RC2 for a few weeks, and then when they release, we will release. But please ask in the GitHub channel or on Twitter if you have any questions about whether something is actually ready to be used or should be used in production or not, because we are going to be testing them heavily. One more thing, this cannot be seen properly. One project we have been working on, this is the shameless plug moment of the day. We had a lot of limitations when trying to monitor ACA, and basically any application, because of the fact of not properly knowing how to aggregate percentiles, or applications not knowing about the frameworks and tools that we're using. So we decided to build something. We're building a service that knows what ACA is, not what's a dispatcher, knows about tracing, knows about HDR histograms and percentiles, and keeps them and aggregates them properly so that you can get basically anything that you need, any percentile that you need, alerting, and so on. So if you're interested, we will be starting a private beta next week. So go to camino.io, sign up, and hope to see you there. And that's it for today. Thanks a lot for coming, and we'll open for questions now. Hello?
Yeah, what's the overhead?
Man, why people always ask that? No, and you know what? There is a task pending for us, which is write a blog post about that. Did any of you read the Nano Trusting Nanotime blog post by Alexei Shipilev? Yep. In this blog post, this guy is exposing things that are expensive become less expensive depending on what you put it next to. So if you are monitoring actors that are receiving a message that does +1 in a counter that is internal state, the overhead of monitoring that is certainly much higher than actually the mutation that is happening when this message gets processed. So how can I answer your question? We have people who use it in production and they don't see any change, any difference. Like for them, it's the same with or without it. But we want to go through the process of doing this test. Like have an actor that does no work. How much do I hurt the actor system with or without Kamon? Then what if the work takes 1 millisecond? What if it takes 2 milliseconds, 3, 5, and see? And what we hope to find, intuition aside, is that the bigger the work is, the less the overhead will be. That's how it logically seems to be, but we don't want to say it, we want to prove it. We want to have the numbers and show it so that people will actually know. If somebody has any experience on performance overhead or see that, oh, there is a lot of overhead when we use it in our app, please let us know so that we can fix it or at least know if there's some corner case that we didn't take into account.
Are we planning to measure the overhead, not only performance issues, but questions like memory consumption?
Yeah, in all senses. One of the things about this is that HDR histograms are allocated when you create a metric for the first time. And then this same histogram stays there during the whole lifetime of the app, and every time there is a tick, we take a snapshot of this, which is a smaller version of the histogram that only contains the buckets that actually have values. But that is some allocation that happens once every minute, and if you have too many time series, then each of these is going to take a few Ks of memory, and if you go crazy and have thousands of them in memory, then that's going to impose some overhead. It needs to be moved around until it graduates. It's a thing. But yeah, we plan to measure that as well.
I'd like to know whether you're happy with aspect J and the reasons are that they're using
Yeah.
possibilities?
I'm glad that you asked that because I actually forgot about mentioning something. I'm not happy with AspectJ. I'm not happy with the bytecode that ends up after this is being read. I think AspectJ has a lot of features that require certain level of complexity and checks when they instrument the code, but we don't need all of that. We just need before, after, around. We need very simple things. And we have an ongoing project which actually already has support for Kamon 1.0, already supports akka instrumentation and futures instrumentation. That is our own agent based on byte body. So it's currently being tested a lot, and it's in our roadmap to have 1.0 be released with the Java agent, with the AspectJ agent, and then release 1.1, which should be basically the same APIs and everything, but all instrumentation will be based on our own agent, not on the AspectJ agent. And preliminary tests say that it reduces a little bit the overhead. Diego, the other Kamon member #1, is heavily investing on this. He's working a lot. He's really excited about the results he's seeing. And I'm like trying to get over with the 1.0 release so that I can also jump into that and get a new agent that will be awesome, I hope.
Any more questions?
Yeah.
Okay.
Are you planning to support any other akka projects such as akka streams or akka HTTP?
Yeah, akka HTTP, actually, we have support for akka HTTP in the previous version, and we manually wrote some directives and wrappers around the client to use it in these things that you saw, but yeah, there will be support for akka HTTP. For streams is another topic. Like, it's not about collecting the metrics, it's about what makes sense. Like, if I showed you actor metrics, they make sense. If I showed you HTTP request metrics, they make sense. When you are with streams, then it depends on what your intent with this stream was, what you want to achieve. Yesterday, he was showing these circular streams. Like, how do you monitor that? What can you offer as a default abstraction to monitor that? Like, we don't have enough expertise with streams to come up with an idea that we can share with people. But if you want it, then like, grab me. Let's talk about how you're doing streams, what is important for you. We want a lot of feedback because we're not using streams that much. So the more feedback we get, the closer we are to actually providing something. But this doesn't prevent you from using the metrics API to put some probes around the code that you know is running within a stream. Like, you can do it anyways. There is no limitation on that. You're just not getting automatically recognized metrics for the streams. Any other questions? No? Good? Okay. People, there are stickers here, down here in this little box. If you want a Kamon sticker like these ones around here, so just go there and get it. And thanks a lot for coming. See you around.